Alright, hello everyone, this is Mr. Crozier, and I'm going to go over the two problems from eLearning today if you missed it, or if you were in first period when the sound was not working. Alright, your assignment is the lesson 2.3 PVA 10 questions assignment. I'm going to do the first two, the rest of them are yours. And remember, in the back of your mind at all times is this idea of calculus that if we take the derivative of a function down this scale, we learn how it changes. Position, the change in position is called velocity, and the change in velocity is called acceleration. And we take the derivative, we just go down this chart. So question number one says the velocity of a particle is right here. So we're starting with velocity. So just, that's kind of something important to remember right there. We're starting with velocity. This equation gives the velocity. And it's about a particle that's moving along the x-axis. So we have a particle that's moving right if it's positive, and it's moving left if it's negative. So when it's going to the right, the numbers are increasing. When it's going to the left, the numbers are decreasing. Usually we go up and down, but in this case we're just going right or left of the axis. So if I have this function, which of the following describes the motion of the particle at t is equal to 1? Well, if you look on my calculator, let's see here. There we go. I have that equation put in there for the first one, for y1. And if I just go to the home screen, I already did it right there. y1, well, I'll show you how to get that. If you want to get that, you can go to hit this variables button down here at the bottom. Right at the very bottom, hit variables. Go over to equation 1, plug in 1, and there's a velocity. The velocity of this particle is, the velocity of 1 is 1.91 units per, they don't tell us, but we could just say seconds. So it's moving 1.9 units per second, positive to the right. So this particle is moving right. So it's not A or C. Alright, but what is its acceleration? Well, if I want the acceleration, I take the derivative of velocity. Now, not the second derivative here, because I'm in velocity. So what you have to do is just, I'm going to do on my calculator, math 8, derivative of y sub 1, because y sub 1 is the velocity, and if I take one derivative, I'm down to acceleration at 1. And there's the acceleration. The acceleration, take one derivative, I'm going to call it a of 1 is 1.61 units per second squared. So that means it's speeding up. So it has a positive acceleration. So this particle that's moving back and forth here is moving to the right, and it's getting faster and faster and faster. It's moving this fast, and it's getting this much faster every second. Again, just be careful. Some people see this and they think acceleration, so they think I have to take two derivatives. Not always. If you're in velocity, one derivative will get you to acceleration. Alright, number 2, the velocity. So again, I'm at velocity right here. They're starting me at velocity. The velocity in meters per second of a certain type of wave is given by this equation. So here's the equation for velocity. Alright, as a wave moves through the water, what is the rate of change in meters per second? So that's meters per second squared of this velocity. So how is this changing? Again, all I have to do is take one derivative, and that tells me how this is changing. That's what a derivative does. It describes how a function is changing. Alright, take the derivative. If you notice, this one is a calculator problem. This is not a calculator problem. So we have to do this derivative by hand. Well, that's the 1/2 power. Multiply it down, that's 3/2, h to the negative 1/2. That's 3 over 2 root h. And I'm looking for the velocity at 2. So just 3 over 2 root 2. And there it is. They didn't bother to rationalize it, which is fine. And we have a positive velocity. So these waves are going this fast right here. and they're speeding up by this rate right here. The waves are getting faster and faster and faster. All right, hope this helps with your homework. All problems, keep this in the back of your mind. Think about where you're at, and if you want to move down the levels, take the derivative.